My name is Zbigniew or Zbyszek, and I'm paid by Red Hat to work on systemd upstream. And I also do systemd packaging and other packages in Fedora. So I have to deal with bug reports and crashes and core dumps a lot.
Hello, thanks for tuning in. My name is Luca. I wear many hats, although not a red one. Among other things, I am a systemd developer and maintainer. I am a Debian developer, and my bills are paid by Microsoft, where I work as a software engineer in the Linux systems group. So today we are here to talk to you about storing packaging metadata inside health binaries and libraries. So first of all, let's have a quick sneak peek of the agenda. Spoiler alerts. In the past few years, generating, analyzing, handling core dumps has improved a lot, especially for desktop use cases. But we think there are many important use cases that are not very well covered, and where we think we could do some improvements to help our support engineers and our maintainers save a lot of time and a lot of manual work. So we're going to look at our proposal, what our end goal is, where we want to be. We're going to look at what we've done so far and what's left to do and how we can get there. But first.
So this picture shows the lifetime of a program that is first starts on the top left corner, and we as the maintainers, we produce some compiled object to distribute it to users. And at this point, we have all the information, all the possible metadata, full debug symbols, and so on. But as we move, before we send the file to users, we strip debug symbols, we remove a lot of the metadata. When the program is on disk, it is still quite well known. The user can easily look up in the package database what is the version of the package and so on. But when the program is in memory, things get a bit tricky because in the meantime, maybe the packet was upgraded or even removed. So something that is running in memory, the version may not correspond to the installed package. It may not correspond to the installed versions of the libraries that this program uses. And well, programs crash, unfortunately. And when users try to report this to the maintainers, they get version information wrong quite often. This is especially common during package upgrades where you have multiple versions of the package that are involved, and well, it's confusing and it's easy to get wrong. And when the information about the crash goes back to the maintainers of the package, to actually make use of this core dump or the backtrace, we need to go undo all the steps and retrieve full information about the original version of the program and the debug symbols.
Yep, so in an ideal world, even if things crashed, all your ducks would be in a row and your nice desktop would provide you with a button to click, and you would just look at the program, which would be in the same distro that you're running. So it's shipped in there. So you have the packaging metadata, you get it from there, and your distro is nice enough to set up a debugging for the server. So using the build ID, it could go and fetch the symbols and any other metadata and provide a very nice bug report for your maintainers. Now, unfortunately, software doesn't always work as we want it to, and especially users do the weirdest things. And especially lately, these weird things very often involve containers, because of course they do. Now, when a program crashes in a container, what happens is that the kernel on the host creates the core file. And then if you're running systemd, then systemd core dump will receive this core file on the host, not in the container guest, analyze it and put it somewhere on the disk. Otherwise, if you don't use systemd core dump, it will be saved in a file system location, again on the host. So if you're looking at a core file, what you have is the core file properly stripped. You have a file name of the executable, and you have a build ID, possible multiple ones from the libraries. And if you're tasked with figuring things out, you have to do a lot of following the crumbs manually. For example, say that you have many containers. Which one do you go and look into it to go and find the packaging metadata for the executable that just crashed? Let's say you can find out because your orchestrator is able to tell you. Is that container still there? Is it still running? Orchestrator can swap these things in and out when they want. You analyze core files asynchronously. Even if the container is still there, do you have access to it? Maybe you are running in an unprivileged context and you don't have permissions to go inside a container, look inside its image, and to get its packaging metadata out, to figure things out. Even if you have this access, which package manager do you use? As we've seen in this great conference so far in these talks, there are many, many, many package managers, way more than I thought existed. Which one do you go and use? You have a Debian host running a Fedora container. Do you go and try and use RPM in the Fedora container? What if the program that crashed was from a binary wheel installed by PyPy? What if it was an executable from Anaconda? Even if you are able to figure out which package manager to use and you have access to the container and it's still there, people like small container images. Now, on my machine, which runs Debian stable, varlib dpkg, which is the location that stores the dpkg packaging database, is 160 megabytes, and that's a lot. So very typically, people preparing container images go and strip them and remove the RPM and dpkg and what else databases to reduce size because they don't care about it. They upgrade containers not by doing apt upgrade or DNF upgrade. They throw away the image and get a new one. And with these people, like our hair raises up on our head and say, "No, you cannot do that." But people do it anyway, and very often it's our job to support it. So, but even if you have container images that are not stripped, your programs might not come from a package manager. Because again, this is PackagingCon, but people do that. They build binaries, put them in images, and ship them and use them in production. It's a thing that happens. So there are many, many use cases where we think we can improve things quite a lot because your DAX may not be line in a row. And with a little bit of work, we can make the typical case where you have a core file easier because you then have all the information you need right there rather than going and following the crumbs.
So the idea is to attach basic package information directly in the binaries, so in the programs and in the ELF libraries that they link to. And this information, well, we have the name of the package and the version of the package, and this needs to be namespaced by the vendor because, well, names repeat, versions repeat, so it's kind of a free-form data in the sense that different vendors, so for example, Fedora has some naming scheme and some versioning scheme, and Debian has some naming scheme and versioning scheme, and they are not the same, but as long as we are within a given vendor namespace, that is okay. And if we attach this metadata to the binaries themselves, they're part of a core dump, and then when a user sends you a core file, you avoid this stupid round trip where you say, well, okay, from which distribution this was exactly, and which version, and then are you sure it was this version, and so on. And it makes it easier to analyze the data. You might not care exactly about packaging details for some foreign distribution, and you might not be even willing to run the code. But if you know the exact upstream version, then if you're an upstream maintainer, it can already tell you quite a lot, even that maybe this version is too old for support or whatever. And we want this information to be attached to the binaries in a way that it ends up in the core file and is usable without network access or package database access. And this means that you can display some initial information about a crash, even in a very limited environment. So Luca talked about the case of containers. For me, a more interesting, different case that is interesting is init-RDs. If some program crashes in the init-RD, there is no network, there is no disk access, there is no package database, there's some very basic system that can maybe display some text on the console. And I think it's much more useful to be able to say that, well, not that, I don't know, some program crashed, but a program with this version from this package crashed. Maybe the user can even take a photo and send it to the maintainers. This information serves as a stepping stone that helps maintainers asynchronously later on retrieve additional information like the debug symbols.
So let's look at some details of the implementation. How do we make sure then that this information is always deterministically and surely available in core file? This case was already solved when the build ID specification was created. The way that you ensure that a build ID is part of the core file is by encoding it into the health header of each executable and shared library, specifically in an allocated PT node. If you do this, the kernel the loader will load it in memory when the program is executed, and then when it crashes, the kernel will automatically take that and put it in the core file because it's part of the memory image. So the idea was, let's do the same thing. Let's create a new package node, and let's have some other way of encoding more information on top of the build ID. The build IDs are very useful for machines. It's a hash, the deterministically generated hash at build time, if you are not familiar with it. They're not very useful for users because they're very opaque, and without other information to go with it, you can't use them for much. So we came up with this specification that can be read on this website linked here for encoding package metadata. And given we are very creative, we called this new ELF section that has packaging information node.package. And then there's again a very randomly generated node ID and an owner, which is the initials of freedesktop.org. These are the low-level details of the ELF format. Now we look at the payload.
What we put there is a simple key value dictionary formatted as JSON. We experimented with a few different things, in particular with like a set of nodes, but it's more space efficient and just easier to have a single node with a blob of text. Well, this blob of text specifies the vendor. So the CP key is a way to specify. It's an external format that tells us what distribution this is, and then we have like the name of the package, the version, the architecture, and since this is JSON, you can add new keys. Parsing is trivial. There's a million libraries to do it. So in the specification, we define how the few most basic keys should look, but it's we can add new ones in the future, and people can add their own if they think it's useful. In particular, after publishing this, initially we got a request or a suggestion to standardize a debugging for URL. So the URL which you can follow to retrieve the debug symbols later on when you have network. Since, I mean, you generally have different debugging for servers for different distributions and so on. And this is a fairly lightweight thing. It comes out to 100 to 200 bytes added to the binary. So essentially it gets lost in the noise.
So we've prepared some proof of concept scripts and tools to create these and to integrate them at build time in package builds. You can find them on this repository. We have a common Python script that will take some metadata in and will generate a linker script. The linker script is then injected by the package-specific tools at build time via LD flags, so that you can have multiple binaries in your package, and they will all get stamped with this information. Now, I want to stress out these are proof of concepts. They're not final. Integrating into various distributions might look very different, and that's perfectly okay. We put them there to show how this works and to show that it can work and how it looks like. And we have the integration done for RPM and DEP-based builds. If anybody is interested and is working on a different type of distro package manager, please do reach out, send us a pull request or anything else, and we'd be happy to store more scripts and integration tools in there. We already have a first use case that's employing this in production today, and that is the Microsoft Mariner. If you're not familiar with it, Mariner is a first-party open source distribution built by Microsoft. You can find it on GitHub. It's RPM based, but it's entirely in-house. It's not a derivative. And thanks to the work of my colleague Ismail and other in the Microsoft team, V1 of Mariner already is shipping binaries that use this format and this metadata specification to encode information. And at the moment in V1, it's OS metadata, so the Mariner name, version, and other OS level information. But the work has already been done, and in V2, which will appear at some point, the binaries will start including package level metadata too, using the common format and the examples that we saw before and that are on the public specification, and also some custom formats. It was quite interesting for me to work on this because more or less the same time, completely independently, developers in the systemd team and engineers inside Microsoft came across more or less the same problems and thought about more or less the same solution. It was very, very similar. So given I have a foot in both shoes, was fortunately able to build a bridge there and start a collaboration, and so that we have a common specification that we are starting to use, and Mariner is the first case. Hopefully more will follow.
And well, this is a real example. So this is the stuff that gets passed to the linker to inject the node, and there's some header and really a bit of JSON, and it's really simple, and it's also simple to consume, right? Because you can extract this node with readelf and convert it back to text, and then just, I don't know, use JQ on it and post-process the JSON.
So I've done the work for the systemd consuming side, which is available as a preview since v249, which we released a few months ago. So there are two sides to this. First of all, if you run the ctl info command, you will see something like this. Now, of course, this is a slide, not a terminal, so I had to reformat a bit to make it fit and make it readable. So it's a lot of cutting, but the basic information is there. You run ctl info, and you will see it will be pretty printed with the package name and the version, and also now the build ID. So in case you're a maintainer and a user typically sends you the output of this, it will automatically include this information. So you can avoid the back and forth that my co-presenter spoke about before. And we think this could be quite useful to save maintainers some time. And the second use case is the journal. Now, Sydney Core Dump will not only print the information in the command line, but we also attach it to the journal. So if you're not familiar with it, systemd core dump analyzes a core file, attaches metadata to the journal, and then compresses and stores them. If you run the journal-ctl command, what you typically see is the message field in the non-verbose mode. And this will already include, in the message that says process foo crashed, we already include the basic metadata like the type of packaging, the name, and the version. And again, we put this in as an initial version. If people find other fields that would be useful to include in the default visible message, let us know, and we can do that easily. But more importantly,
sorry, Luca, you are at 2 minutes over, and if you could wrap up, that would be awesome.
Yes, indeed. So let's move on. The full metadata is included in that field there. Now let's skip the FAQ because we covered it at the beginning.
Okay.
So
for this
last sentence is that we are it's using Mariner. We are proposing this for inclusion in Fedora 36, and we hope that it will gain wider adoption in the future.
Yeah, I will, after Fedora adopts it, I will propose it in Debian. That is my plan. And that's it. Sorry, we went over time. Any questions?
I'm sorry, we don't have time for questions, so I will just keep moving on. And thank you so much for that very informative talk.